Hello and welcome to Learn Synthesis with Pure Data. If you are interested in learning the art of synthesis, or if you're interested in learning the open source programming environment Pure Data, then this is a series for you. Hello, I'm Dr. Lawrence W. Moore, and I'll be your host. This is a series that has multiple parts to it. This is Series 1 in the overall Learn Synthesis with Pure Data series. And in this series, we're going to start off with the fundamentals of digital audio and synthesis, and we'll be learning the open source programming environment Pure Data. The reason why I use Pure Data in this series is because it is a free download. It's basically accessible to everyone with a computer. It works on both Windows and Mac, well, in addition, Linux. And it's basically something where we'll be able to build synthesizer components and software. We'll be able to, by the end of this series, build our own simple synthesizer. And it allows people to learn the concepts of synthesis from a fundamental level. In other words, you'll be learning the terminology that you can apply to software synthesis as well as hardware analog synthesis. You'll be learning the components of a synthesizer from the ground up by making them in software, so you really know what things do. And it's the best way to learn because you'll be able to apply this knowledge to any software in the future or hardware and have a much better idea of what you're doing and what those different knobs and faders do. So, without any further ado, we're going to start the series in this episode 1. We're going to learn the basics of Pure Data, as well as some fundamental digital audio concepts. Okay, so you follow me here. We're going to start off at the puredata.info website. This is where you can download Pure Data. If you go to the download tab here at the left, you'll see some options here. What we want to download is Pure Data Vanilla. Pure Data Vanilla is the Pure Data release that is managed by the founder and creator, the original developer of Pure Data, Miller Puckett. Miller Puckett is a legend in the electroacoustic and computer music media of composition. And Pure Data is basically so open-ended as a developing environment that it's a programming environment that's developed for artists in that you don't need to be a hardcore programmer to learn it. And at the same time, it's a visual programming environment, so you can develop your own systems that you want to use, basically like developing your own apps, but they run only within the Pure Data environment. But that being said, you still can basically develop your own software for audio work and music creation and all sorts of things, and we'll be using it to build a synthesizer. Here are the downloads. One thing that I will say is if you download it for Mac, you may have to go into your system preferences and allow it to be opened because in recent years, it's not on the Apple list of approved software, probably because it's a free download, it's open source development, and nobody's really making money, so they don't want to pay to be on the list. But basically what you can do when you download it for a Mac is after you try to open it and it gives you that message that it can't be opened, you can go into your Apple icon on the upper left-hand corner of your screen, you know, the far left icon on your menu bar. Go to System Preferences, go to Privacy and Security, and there should be a message where you can allow it to open. Another shortcut to this that's worked for me in the past when I've taught this in schools that used Mac is that you can also right-click on the software that you download and go to open there. And that, at least in the past, has given an option where you can open it anyway. Whereas if you just double left click, it gives you a message that it's not recognized software and it doesn't let you just open it directly. But either way, that system preferences and privacy and security option is the definite way to get it working. Now, for Windows users, you can get the standalone version or you can get the installer version. If you're comfortable with using standalone software, you can download that package, open it up, and inside the folder, you'll go into a folder called bin, and that's where the application is. If otherwise, you know, just get the installer version. This will install it to your computer, and you'll get an icon, a desktop icon, to open it up, and away you go. Okay, so that's how you get the software. And now we're going to open it on my computer here and get our first lesson. So anyway, this is just where I have the Pure Data app. And you see when I open it, thing I get is this. This is the PD window. This is a window that's really kind of like a control panel for Pure Data. This menu bar that's appearing on this window in Mac will appear on the top of your screen. You know, in Mac, basically whatever application you're in, you'll have a menu bar there that changes as to whatever app you're in. If you click on the desktop, you'll see the menu bar change back to Finder. And when you click it on the PD window, it'll change back to PD. To see what your app you're in Mac, just look at your menu bar at the top, go all the way to the left, and just next to the Apple icon, it should say PD. That means you're in PD and it's up and working. And if you click out of it, it'll say whatever app you clicked into, or Finder if you clicked on the desktop and you're just in the Mac operating system itself. So just make sure this is selected so that the menu bar you have in Mac is for PD at the top. In Windows, it appears right in the window. So the first menu that I'm going to call your attention to is the media menu. We want to make sure our sound is operating. I'm going to come back to this later, but I'll mention it now. There's a DSP on and DSP off selection here for turning on and off DSP, which basically means turning on the sound flow on in PD, like audio and sound will be running, or to turn it off. And we'll see the uses of turning it on and off as we go. But I wanted to point it out. A good thing to go to is to the Test Audio in MIDI option here. What this opens up is what's called a Pure Data patch. And we'll be making our own patches quite shortly in this video. A patch is almost like what a document file is to Microsoft Word. Basically, this is where you make things and edit things, is in a patch window. This is a patch window that was built and included in PD, that when you run that Test Audio in MIDI, it opens up a patch that's pre-made that allows you to test your audio in MIDI. We'll be getting to MIDI later in this series, but right now we can test our audio. If you click these boxes over here to the left, where if you click the middle one, you hear a tone. Click the top one, you hear a louder tone. I just turned it off. That's all you need to do. If you hear sound, then that means, okay, I got sound coming out of my computer, so it's obviously set for the right audio device. Otherwise, you go into MIDI here, media, excuse me, and you go down to audio settings. Yep. And here you can set your input device and your output device. Input is where you want sound to come in, and output is where you want sound to go out. In this first lesson, we will be using both our inputs and outputs. We'll be recording sound in with a microphone and hearing it come out. If you don't have an external microphone, you can use the built-in microphone on your computer. That's fine, but you want to make sure it's set for the right devices. Only you know what devices you're using, so you would click the in and out here and select from the list what device you're using. Up here at the top is the sampling rate. I suggest to keep it at the default for now at 44,100, which is basically the CD audio quality standard. It's the lowest sampling rate for working in music and having it sound decent. But it's compatible with everything. So just about everything. So that way you'll be able to play anything you make on your computer, your phone, whatever, when we export things to audio files. But just keep in mind this concept of sampling rate, because we'll be talking about that in a bit. Right now we're at 44,100, which means 44,100 samples per second. We'll explore that concept further. Okay, so I'm going to close that. What we want to do next is go to the File menu and go to New. This opens up what's called a new patch window. Remember I said before that patch windows are where you make things in Pure Data? And we'll be making a simple patch today to learn how Pure Data works, and also to go over some of the basic digital audio concepts, such as sampling rate will be the main one. Okay, so you see it's a big blank space. It's almost like a document that's empty. It's a blank page. Up here we have some menus. I'm going to point out items as they come up in my overall flow of teaching. But right now, one thing I want to point out is the Edit menu. At the bottom of the Edit menu, you see Edit Mode. And there's a shortcut for that listed to the right. We'll be learning a lot of shortcuts in this series because it makes things faster and easier to do rather than going and browsing through a menu and selecting options. But Edit Mode, as you see, is checked off, and it has a shortcut Control E. That will be Command E in Mac. Most of the shortcuts that we'll be going through are Control key shortcuts in Windows, and in Mac they're Command key shortcuts. But you see right now my cursor is a finger, well, an index finger pointing out from a hand. And basically if I hit Control E, which is the Edit Mode toggle shortcut, you see it becomes an arrow. As we go through using this software, the arrow key denotes we're in run mode. And when you hit Control E again, it goes back to the hand. This means we're in edit mode. Edit mode is when you're building things and editing your patch, making your whatever it is you're making. And then when you want to be able to click on some of the items in what you're making, we'll see this in a moment, you go into run mode. That means you're no longer moving things around or editing them, you're now using them. So just keep that in mind, edit mode and run mode. So next we're going to go to the Put menu because we're going to start making something. In the Put menu, there's a list of different things that you can put, all these different items. One of them at the top is called an object. We're going to select that. But bear in mind it has a shortcut too. Control 1, Command 1 in Mac. And you see what it makes? It makes a little dotted outline box that's highlighted blue. Basically, if you click, you put it down, and it means you put it down somewhere, and now we can take this object and define what kind of object it is. In pure data, objects are things that perform functions, certain functions. And in order to define what type of object it is, and therefore what functions it performs, you need to type in it. And there's basically a whole list of object names that basically allow you to define what an object is, and it basically is a whole list of different objects that do different functions. What we're going to make first is an object called WriteSF, and we're going to spell that W-R-I-T-E S-F. And now I'm going to click outside the box, and I'm knowingly doing this, and you'll see it still has a dotted outline. Let me zoom in by hitting Control plus, Command plus a Mac to see it bigger. And this dotted outline and this red message over here in the PD window are telling me something. It's saying that this object is not recognized. Basically, WriteSF on its own is not an object recognized. In other words, it doesn't know what this is, so it can't really make an object. And that's what the dotted outline means as well. So I know what I did wrong. At the end of WriteSF, there's a symbol called a tilde. If you look at the horizontal number strip on your computer's keyboard, 1, 2, 3, 4, 5, 6, 7, 8, and so on, to the left of that, there's a key all the way to the left side of your keyboard that of a standard keyboard. There's one there that has 2 symbols in it. If you hold down the Shift key and hit that key, you'll see it gives you this little squiggly. And that is a tilde. Now I'm going to click outside the box again, and you see it becomes solid now. And it has this little highlighted section at the top called an inlet, which we'll talk about in a bit. But since it recognized what I typed in here now, it knows that this is a WriteSF object. And what WriteSF does is it writes to a sound file. And that means that we can use this to record sound to an audio file. And that's what we're going to do. Now, the first thing we need to do is feed this thing some sound so that it actually has sound to write to a file. And what I'm going to do is make another object, Control 1, Command 1 in Mac, click it down, and I'm going to type A, D, C, and a tilde again. Now, not everything's going to have tildes in pure data. Tildes are for objects that actually carry sound. And so, WriteSF obviously carries sound because it receives sound through its inlet, and it writes it to a file, a sound file. ADC stands for Analog to Digital Converter, and it represents your input. So remember when we were in the media menu and we went to the audio settings and looked at what the input was? That is your input, and this represents it. And it has these highlighted sections at the bottom that are called outlets. Look how when I put my mouse cursor over them, it becomes a circle. This means, and I'm going to do this, I'm going to put it over this outlet here, click and drag, and I can connect it to the WriteSF. So I'm connecting the input of our sound, which is on my system set to a Motu interface that I have, and its first input, which is the left outlet here, is now connected to WriteSF. So sound would come from that input into the WriteSF object where we can write it to a file. Okay? This outlet here would be for your second input. And depending on how many inputs your device has, that's how many outlets you may have. Although by default, ADC only gives you 2. If you want more, you need to type in the number of inputs that you have. After ADC tilde, you put a space and type a number for the number of inputs you want to have. And it'll give you that many outputs on the bottom of the object. So that way you can have like an 8-channel interface with 8 inputs and have 8 different inputs here on your ADC. We're not going to do that because we are fine with this. We're just using one input for a microphone. If your input device is a built-in audio on your computer, just use this left outlet here because that will represent your microphone on the computer that's built in. Okay, all right, so we're going to learn more and more as we go. Now what we need to do is to tell WriteSF what sound file to write to. Before I do that, what I'm going to do is go up to File and Save. A lot of times early on in making a Pure Data patch, you want to save your patch file. We want to save this patch window to a file. It'll save to a file that's called a PD file. And since I'm in the Windows version, and lately Windows versions have made like default folders for PD patches in your Documents folder, that's where it took me to by default. There's an Externals folder here that is for when you add external like plugins to Pure Data or external objects that you want to add. We can talk about that later as we go on in the series. It's going to be a long adventure from this point. This drum machine folder is a Pure Data patch that I made before. And this is the folder I made for this series. So everything I'm making for this series I'm going to keep in here. Learn synthesis with Pure Data. Series 1, meaning like chapter 1 in series 1, we're starting with the basics and going off to building our own simple synthesizer by the end, and then we'll start series 2 and get more and more advanced as we go. Episode 01 is this episode, so this is where I'm going to save it, and I'm just going to call it S01E01 for series 1, episode 1. There we go. So by doing that, I've given it a home. Now I have previously opened up this folder here on my computer, so you can see it saved that file. On PCs it has a .pd extension, which you're not seeing, but it gives it the PD icon, and in Mac it'll give it a PD icon too, so it should open automatically with PD whenever you double click on this file, just like you do with files that go with other applications. Okay, so that's where it is. It now has a home, and that'll be important for what we're going to do next. Now, what I'm going to do is, you see in the Put menu, below Object, there's something called Message. An object box performs functions. A message box sends messages, and it has the shortcut Control 2, Command 2 in Mac. So I'm going to do that. And here we have a message box. You can see the difference between an object box and a message box. Message box only has one inlet, one outlet, and it has this curved section to the side. And so what we're going to do is make a message for WriteSF to tell it what file we want to write to. And the message we're going to send is a message called open. O-P-E-N, open, space, and then the file name. I'm going to call it temp, abbreviation of temporary, .wav, meaning it is a WAV file, one of the main types of audio file formats. And then we need to connect its outlet here to WriteSF so that it sends this message to WriteSF. Now what this message is to tell it this is the file we want to write to. Don't let the word open throw you off. We're not really opening a file. Write SF is kind of like opening it to use it. And if the file doesn't exist, it'll make it. I'm going to hit Control E right now to switch to run mode. So we have the arrow key. Remember that from before? If you ever forget that shortcut, just go to the edit menu. It's right at the bottom. You see edit mode is not checked off. That means we are in run mode. And that allows me to click on this message box. You'll see it highlight, which means that the message has been sent. There we go. Now I'm going to go to the file folder down here. And we'll see we now have a temp.wav file. Well, you don't see the .wav, but it recognizes it as a WAV file. It puts the symbol here of VLC, which is my media player that I use. And so we now have a WAV file with no sound in it. But this is why I saved the patch, so that the patch file, S01E01, has a location, because by default, your file for audio file is going to be put in the same location as your patch file. So we wanted to give it a location so our audio file would automatically have a location. So there we go. Now, as I said, it's an empty audio file because we didn't put any sound in it yet. Write SF works this way. It records sound that's coming into it. Our sound is from this ADC tilde object, which means the input from our sound device is coming into Write SF. But we need to tell it to start recording that sound and to stop recording that sound when we're done. So we're going to make two more message boxes. I'm going to go back into edit mode by hitting Control E, Command E in Mac, hitting Control 2 to make another message. And this message is simply start, which means to start recording. And then I'm going to make another message box again. The same shortcut, remember Control 2, Command 2 in Mac, and a message stop. Now I'm going to connect both of these up to the inlet to Write SF. Now you see all these things are connecting to its only inlet, its left inlet. Some objects have multiple inlets. Some only have one, some have none. Depends on whether they receive information or not, or if they receive information through an inlet. Now, I'm going to show you something else about PD. If you take an object that's been made and it's valid, you can right-click on it, and you can go down to Help. And here, you see a kind of like a brief help file for that object, just to kind of remind you of some things in case you forgot certain things. And this shows you the different types of messages that it receives. Some example messages. So I wanted to show you that. I know that all these messages that we're sending are valid. And basically, we're going to use them now by going into run mode. Now, before we do this, since we're about to use something that uses sound, we need to make sure our sound is flowing. So we go up to the media menu and make sure DSP is on. Since we did the test audio patch before at the beginning of this episode, it automatically turned on DSP. But normally when you're in a patch and you're building something, the DSP will by default, when you first open PD, be off. So you always want to check this and maybe memorize these shortcuts. To turn it on, it's Control /, turn it off, Control period. Obviously in Mac, those will be Command / and Command period. So those are ways to do it without opening this menu. I'll also show you a way, by the end of this episode, how to turn on this patch's DSP when it starts up. Like when you open the patch sometime in the future, its sound will already be flowing, so these things will work. If I didn't have DSP on, no sound would be flowing from ADC to Write SF. But right now, the sound is flowing, so everything I'm saying is being sent to Write SF. It's just not being written, because even though I selected the file to write to, I didn't hit start yet. So now I'm going to hit start. Hello, how are you doing? and then I hit stop. Remember, you need to be in run mode to click these message boxes, have them highlight, and have them actually send their messages. So Write SF received those messages, so it should have, when I started, wrote to the file, I added the audio to the file, and then when I stopped writing the audio to the file. Now we can open the file. And one thing is, if you skip any of these steps, things won't work right. First of all, you need to have the open message and a file name to tell it what file to open and use. That must be done before you hit start. And then you hit start to start recording, and you can say something, it'll record it. And then you have to hit stop before the file will be usable, because otherwise Write SF will have the file open and it'll be currently recording to it, so the file won't even be usable. Like, you can't double click it and play it until you hit stop and stop recording to it. So now I'm going to double click it. Hello, how are you doing? There we go, and it plays, and we're good. We're good. We successfully recorded to a file. So now we recorded to a file. What I'm going to do next is take that file and load it into Pure Data into what's called an array. Now let me make an array and tell you a few things about it. In the Put menu, it's the thing all the way at the bottom. And it has a shortcut, Control-Shift-A, Command-Shift-A in Mac, to make an array. And when you click that, it will give you this menu first. This is a properties menu for the array. Before it makes it, it definitely needs you to do at least one thing, and that's give it a name. Now, in Pure Data, there's rules for these names, because in this case, this is a name of an array, and the array is communicated with by using its name. So Pure Data keeps track of names and associates it with this array that we're making. And there's rules for making names in Pure Data that are part of what we call the syntax, almost like the rules of grammar in language. Programming languages have syntax, which means the way in which things are done. Otherwise, it won't understand it. Or there'll be errors because it's misinterpreted. There's two main rules that are required for names, and then there's a third one that I like to use that I think will help you out. First rule, names cannot have spaces in them. Because, as you saw earlier, when I talked about ADC tilde and putting a number behind it to say how many inputs you have, and so how many outlets it should have on it for those inputs, anything in Pure Data is separated by spaces. Its information is separated by spaces. So because of that, you can't have spaces in the name, because whenever you're referring to the name, a space means a new thing in Pure Data or a new piece of information. And yeah, so that's rule number one. I'm going to name this recording. Rule number two, don't use weird punctuation. There's some punctuation that's accepted and some that's not, just to be safe for now, because later we're going to use some punctuation that actually means something, and that's later in the whole series. But right now, the punctuation that you can be safe with is an underscore. An underscore is so that if I wanted to give it like two words in a name, you can avoid having the space, which you can't have by putting an underscore. I could call it recording_1, for example. Letters and numbers are fine. And then an underscore is also fine. So, you know, when you're naming things, if you want to be able to have like 4 different recordings, they are called recording 1, 2, 3, and 4. You can use an underscore in its name and name them recording_1, recording_2, and so on. Now, the third rule is not really a rule, but it's something I like to do. I like to use all lowercase in names because Pure Data is case sensitive. So if we are making some messages or other things to communicate with this table, or array, I should say, then the case is sensitive and will, if I name this recording with an uppercase R, anytime I address it later, I need to have that uppercase R or else it won't work. Okay? So just to avoid knowing whether I have uppercases and stuff like that, I just always use lowercase so I don't have that problem. And it's a great rule of thumb as a beginner especially. Now, I'm going to point this out even though we're not going to change it. Below it, you see it has a size number of 100. This is not going to be its graphic size, like when it appears. This is the size, meaning how many numbers it can store. Arrays store numbers. Now I'm going to go into edit mode. Got the hand there, so I can grab this array and move it. And you see its name appeared above it there, recording. Now, arrays store numbers. And by default, you can change this, but for audio, you don't want to because this is set up for audio to begin with. It has a y-axis that has a certain range of numbers, and it has an x-axis that has a certain range of slots where the numbers go in, that you store in it. The y-axis right now is set in a range of 0, which is this center line, and right now all the numbers by default in this new table or array that we created are 0. Incidentally, now and then, and I've done it already a couple times, I'll call an array a table. For our purposes, the terms table and array are basically interchangeable, okay? So basically, if I say array or table, right now I'm talking about the same thing. So everything in it, because we just made a new one, is 0. So you see a horizontal line going across. Really, these are basically like a series of dots going across left to right. And there's 100 of them. And so there's 100 zeros here in a row. And that's why it looks like a line, because they're all the same number. And the y-axis defines what that number is. 0 line in the middle. The upper top of the array is 1, which would be right in contact with the upper end of its box. And the lowest number is -1, in line with the lowest edge of the box. So you can have a range of numbers in this table and have it fit in as long as they're between -1 and +1. So you have 0 in between those, halfway in between. 0.5 would be here, 0.75 would be roughly here, -0.5 here, -0.75 here. And audio in general, when it's loaded in an array, is going to be displayed in this range between -1 and +1. The up and down of the waveform is going to be going up and down, above and below 0, in this space, because really what digital audio is a series of numbers. Basically, analog to digital converter. When sound comes into your ADC, which means like either the microphone built into your computer or a microphone connected to an interface, when a microphone converts the sound vibrations in the atmosphere, like the sound of your voice, into an electrical signal, it becomes an analog signal. It's basically this voltage signal where it's an electrical current that's, for all intents and purposes, kind of like its strength. More technically, it's almost like the pressure behind a water hose, but we don't need to get into that now. But basically, that voltage raises and lowers with the sound vibrations in the atmosphere, and that way it communicates the shape of the sound vibrations in the form of electricity when it comes in through the microphone. And then that becomes digital information, where basically your audio interface or the built-in chip in your computer that takes the sound from the microphone, they convert it into numbers by measuring the voltage. So the voltage that's going up and down gets measured, and this process is called sampling. And each measurement is called a sample. So you saw before in our media menu, we're using a sampling rate 44,100. That means 44,100 times per second that voltage current gets sampled a number is assigned to it based on where it is in its fluctuations of going up and down, and it assigns it a number between -1 and +1, at least as far as what we called normalized numbering is concerned. So those numbers are assigned to it and they'll fit within this array. So we'll be able to see the sound wave of what we recorded in this array. So let's do that. So what I'm going to do is make another object. I hit Control-1. Oh, it put it down here. Since the last thing I placed was the array, it automatically put it there. Now, I'm going to put this object box here, and I'm going to type in it sound filer. This object does not need a tilde at the end. Click outside the box and it's made. Now, you may say, why doesn't it have a tilde? Doesn't sound flow through it like write SF and ADC? Not exactly. It deals with sound files, but it loads them in and out. The actual sound doesn't flow through the object, so it doesn't have a tilde at the end. But this is what we can use to tell, well, to get that sound file that we recorded and load it into the table or the array. And we can do that with a message. So I'm going to hit Control-2 and make a message box. And this is read space. I'm going to change this later, but right now I'm going to do it this way. I'm going to put the file name temp.wav space, and I'm going to put the table name recording. If I just put that, that message will be understood by sound filer as it's going to read this sound file and put it in this table. And you got to put things in that order. And notice how there's spaces in this message, just like this one here. That's why I said before, names cannot have spaces in them, because every time you put a space in a message or in an object box, it means a new thing is coming up. And in fact, everything here in order is what's called an atom. Just nice bit of trivia to know. But like you type the word read, that's a command. That's an atom. After that, it expects a space before the next atom. And the next one, it's expecting, although it could expect two things. I'll show you that in a moment. But right now, the next thing we have is the file name. And then after that, it expects the table name. So since you're using a read command, it's naturally expecting a file name, then a table name. You can't reverse their order. Now, I'm going to go into run mode by hitting Control-E. I'm going to click this message. And it did not happen. Oh, it did. Yeah, and I actually did this kind of on purpose. You see, there's just space here. It's like nothing came in. Well, the size of this table, which we saw to begin with when we initially saw its properties menu, and we could see it again by right-clicking on it and going to properties. This was the original properties menu that was open, because this is the one you have to give a name to before it'll make the array. And then here, this is another one that opens now. So you can change some of its graphic options. This is how it gets displayed. Like the main way we'll be using this shortly is for its height and width. Like basically visually, how tall is it and how wide is it in pixels, graphic pixels on the screen. That will change how large it is when we display it. That is different though than its size here. Size means how many values are in the array. So here we have the name and here's the size, 100. Remember, we're recording at 44,100 samples per second. That means in 1 second's worth of time, there's 44,100 little dots, little numbers, but they would appear on as dots in this table. And they would appear as dots forming the shape of the waveform. because as the sound vibrations come into the microphone and eventually get converted into digital information, a number is assigned to where that voltage current was at in its fluctuating shape of a waveform. And so it actually did that. But the first 100 samples, which is a tiny fragment of a second, is so short in time, it never got to the point where the sound started. So this is just a little bit of the space at the beginning of the recording. Now, what we can do is we can change the size of the table to 44,100, hit OK, and now it'll display 1 second's worth of time. Or did I do something else wrong because I'm not seeing it? Hold on. No, we have to load it again. We have to tell it to load this file again into this table for it to display. There we go. But now all we're getting is the first second. There may be more after this. And it looks like it, yeah, it does get a little cut off here. I finished saying the word hello, but it's cutting off a little bit of the sound trailing off there. So the way we can do this is there's a way to tell it to make this table the size of the file that we're opening. And the way we do that is we go back into edit mode, Control E, Command E in Mac. And right here before temp, you can put in what's called a flag. Normally it expects a file name next, unless you put a hyphen and then something that PD recognizes as a message command, and that is resize. And then I put a space again. By having the hyphen here, it will read this before the file name, and as long as it's something it understands, like resize, it will read that and do it. And what hyphen resize means is to resize this table to whatever size this audio file is. So now we're going to go into run mode, click this again, and we should see a little bit more space appear to the right. Oh, yeah, there was even more audio recorded, another word. So you can see it's more than a second long. So this is convenient to do, to have the resize there, so it resizes the table to whatever size it needs to be to fit all of the audio of this file in it. Okay? All right, next we're going to do this. I'm going to go into edit mode, Command E or Control E. And now here's something else I'll show you as a neat thing to do. When you click an object and it highlights the words in it, and then if you hit the shortcut for making something afterwards, it'll line it up to the left outlet by default, which is what we want in this case. I know there's 2 outlets, but this one we want the left. And it'll just make whatever we want there. What we're going to make is a number box. In the put menu, you see a number box is the 3rd item down. It's Control 3 or Command 3 in Mac. So watch this. I'm going to hit this, select this, hit Control 3. It hooks up the number box automatically to it with a real short patch cable in between. This is a way that you can start, if you know what you're making in order, you could start making some things and go through it more quickly and not have to connect up patch cables. Now, what this number box is going to be, and actually I'm going to pull it down because I want to give it some space. You'll see in a minute. What this number box receives is the left outlet of SoundFiler always will send out the size in samples of the audio that's loaded in a table. If we go into run mode, hit this message again, reload the audio in, you'll see a plus sign appear. That's a symbol in the number box. It means that it can't fit the whole number in this box. It's not big enough. So we're going to right click the number box and go to its properties. And here you see at the top it has width. This is in digits. I'm going to change it from 5 to 12. Our number should fit within 12 digits. And then there's some other things here like label. Whenever you see label, that means something, it's a name that you could put on something that's just visual. This is not like the name of this table over here, recording, where this is what PD knows this table as. It's called recording. And you have to follow the rules in that. Here, this is just a graphic display where I'm going to say samples, because this is displaying how many samples are in this audio file. You could have it display to the left or to the top. I'm going to put it on the top, and so forth. These boxes for symbols we'll be dealing with later in other things. This allows you to give a name to this number box that's an official name, a PD recognized name. Those are called symbols in PD. Well, at least when they're send and receive symbols. If we want to send information to this number box or receive information from it, we can make symbols, symbol names to basically send and receive those informations. And they follow the same rules as like the name of a table. No spaces, no weird punctuation except for an underscore for now. So I'm going to hit OK. We don't need to use those right now. So it says samples at the top. That's my label. And here's its size and samples. And so, since this is its size and samples, since there's 44,100 samples per second, this is probably 3, maybe 4 seconds long, somewhere between 3 and 4. But we can find out for sure, you know how? With a little bit of math. I'm going to go into edit mode again. I'm going to click here. Remember that trick I showed you? If you click and highlight like an object or a number box or a message, and then use the shortcut for what you're going to put below it. We're going to put an object below it. I'm hitting Control 1. I'm going to type a /. This means divide. And so our first atom, as remember it's called, the thing separated by spaces, is the object name. And in this name, it is /. It's an object that divides. Whatever comes in through its inlet, it divides by whatever number you put afterwards. So we're going to put the sampling rate, 44,100. Because if it's 44,100 samples per second, if we divide the total number of samples by that, we'll find out how many seconds long this audio is. This math box that's a dividing box also has a right inlet where you can kind of put in other numbers. So you could constantly feed it different numbers to have it divide by different numbers. But right now we only want it to divide by 44,100. Now I'm going to select it and hit Control 3 to make the number box afterwards. This is where we're going to see this math take place and give us a result. We're going to see how many seconds long it is. So I'm going into run mode. I'm going to click the message again, because you see it's not going to update until you send this message and actually have all this stuff flow through. That's one thing you have to remember in Pure Data. Like when you add new things, things don't happen until you send the information. So we hit this. And oh, it's actually not even 3 seconds. It's 2 seconds and 631 milliseconds. 6.31. I mean 2.631. Anything after to the right of the decimal point in seconds and stuff is its milliseconds. 631 seconds is more than half a second. 1,000 milliseconds equals 1 second. So 631 milliseconds is a little over half of a second, because it's a little over 500. So it's roughly a little more than 2.5 seconds long. So that's sample rate and sampling and getting numbers and stuff, and kind of seeing how the audio displayed in a table is really just a bunch of numbers. Or in this array, it's a bunch of numbers going left to right in time. And that's how graphic waveform displays are in other digital audio software. Now, let's do this. Let's play this back. And we can do that using an object called tab play. Tab play tilde. And I'm going to put a space because tab play lets you put in what's called a creation argument. When you are making objects, anything you put off after the object name, after a space, is called a creation argument. It's information for that object. And it varies depending on the type of object. First of all, whether it receives a creation argument, and then what creation arguments it receives, like what information you can tell it. Tab play, the first creation argument you can put behind it is the name of a table to play. Recording. Very simple. Now, this object will play the table recording, but only after we send it a signal that tells it to do it. And the signal that we send that is used frequently in Pure Data is something called bang. And it can be done in a message box. Control-2, Command-2 a Mac to make the message box, and simply type the word bang. That simply tells tab play to play the table called recording. Well, bang itself doesn't know that. Bang itself just knows it's a bang, and it's a message that gets sent. Tab play interprets bang as a signal to tell it to play recording. You can hit bang now and hear it. No, I forgot one other thing. Just like we have an ADC tilde for sound to come in to Pure Data from your sound device, we have an object for it to send sound out. And that's called a DAC. I'm going to hit Control-1. It automatically put me in edit mode when I did that. It toggled it for me because it knew I wanted to make an object. And so we're going to make a DAC, a digital to analog converter. And it does have a tilde behind it. If we hook this tab play up to this, then the sound will come out our sound card. So we go into run mode to hit the bang. Hello, how are you doing? And if you're listening in headphones, you'll hear it came out just the left side. See how there's two inlets on DAC? The second inlet is for the second output channel, which is typically the right. One left, two right. You see, it's stereo by default, just like ADC. But DAC also, you can put a space and then a number for the number of outputs you have. So you can use a multi-channel interface, 8 outputs, whatever. So now we'll hear it come out both sides because the sound's being sent to the left and the right. Hello, how are you doing? There we go. So now we see how to record sound, load it into a table, and play it back. We're coming to the end of this lesson, and if you've been enjoying it so far and finding it helpful, please do hit the like button. Don't forget, it helps this video come up for searches for synthesis and Pure Data and things relative. So your hitting of the like button helps me out a lot. Now, I think I said before, there's a way to set this patch so that DSP is turned on automatically. Because remember, DSP in this media menu is a way of turning on and off sound flow. There are times where you want the sound flow to be off while you're building because you're using some audio objects and they'd be sending weird sounds and stuff, that would be annoying while you're still building it. When you're done and things are set up right, then you want to hear it. So, that's what that's for. But next time we load this, it'd be nice if it was just working right away and you didn't have to hit the DSP on in the media menu. There's a way of doing that within your patch. It's a message, and it starts off with a semicolon. Then you hit enter. Now it didn't go to the second line right away. That's just some weird idiosyncrasy of Pure Data, but we're going to start typing, and it'll automatically appear on the next line. PD DSP space 1. PD space DSP space 1, which means, and you see I followed it with another semicolon, what it means, that is a semicolon, right? Hold on just a second. That's a semicolon. What this means is this is a signal to PD, DSP on. And conversely, you can have DSP off if you have a 0. I'm going to select this just so I don't have to make it from scratch again. Hit Control D, Command D and Mac. And while it's highlighted blue, I can drag this down. And now we have the corresponding off message once we put a 0 in place of the 1. So you can turn DSP on and off just by hitting these. Of course, in run mode, so you can click on the messages. On, off, on, off. You see it's off right now. If I press this bang, we don't hear sound. If I turn it on, hello, how are you doing? Hello, how are you doing? We're good, we hear sound. Now, to make sure this is functioning when we open this patch, I'm going to put an object at the top here. Control 1, Command 1 and Mac. It's called a load bang, and it's all one word. L-O-A-D-B-A-N-G. Load bang. That means when this patch is loaded, basically opened, it will automatically turn on DSP. Okay? That means this will be running and ready to go, that you could start clicking the messages to record, and you could then click the message to play back, and it will all go without having to go to the media menu and turning it on. Let me show you. I'm going to close this now. I hit Control S. You've probably been seeing these messages appear at the side here in the PD window. It means that the file's been saved. It's just a habit I have. Control S is a shortcut to save. Command S in Mac. And if you hit it frequently, you'll at least be sure that you've been saving your updates. Now I'm going to close the patch and its PD window. Now watch this. I'm going to open the PD window. And you'll see that whenever PD opens, whether you open it from a patch file or the PD window, by default, DSP will be off. But now, I'm going to open this patch, and it'll open a PD window along with it. It went back to its original size. Remember, I hit Control plus to enlarge it. That's to zoom in, but this is its original size. So I'll hit Control plus again so we can see it more easily. Alrighty. And I'm going to minimize this because in a moment I'm going to take a screenshot. So here we go. But since the load bang was here, which only bangs when a patch opens, it bangs that. We can go here to media and we can see the DSP is on. It automatically turns it on. That's a good thing to know, because sometimes when you make more complex things that people are going to use and stuff, it's nice to have it on to begin with, and they don't have to remember to go to media and turn DSP on. So now we can just do this. Now, since we're starting from the beginning again, we got to tell it what file to open. Since we reopened a patch, you got to tell it what file to open. Okay? We are recording. And you got to hit stop before you can open it up. Otherwise, it won't, this read message won't work right. It'll give an error message saying resize failed, which isn't very descriptive what the problem is, but the problem is you didn't hit stop. So the read function isn't going to work unless it stopped writing to the file. There we go. It's now in the table. We are recording. There we go. We've made our first functioning patch in Pure Data, so congratulations. And if you want to see more of this series and stuff and be notified about, please do subscribe to the channel. And hit the notification bell icon to be notified of new videos, or if not, you don't want to be notified, but please subscribe anyway, so it helps build the channel, helps us grow. I've had channels in the past where I've done PD tutorials and got well over 3,000 subscribers and things, but I'm starting over again at the Wayfarer project because I want to put everything in one channel, all my content. So I'm starting from the beginning, and I could certainly use your help here at the beginning. Let me take a snapshot. I'll use this for the thumbnail. And there we go. So thank you for joining me here in this first baby step on the way of our adventure here. Remember, the series is going to be in like about 11 or 12 episodes long for each series. And then the whole overall series, Learn Synthesis with Pure Data, is going to have who knows how many series in it. They're like chapters in the book. This first chapter, we're doing the basics, learning synthesis, and we're going to make a simple synthesizer by the end. And the next series will be more, well, we'll do more advanced things. And we'll just gradually build and build on the learning process. And, you know, eventually we'll get to the stage where maybe we'll have a series where each episode is its own unit of some new interesting thing I've come up with and want to show you. Some of it may be, you know, pure data patches I develop in the future and stuff like that. It's a whole big long adventure. So please do stay in touch. Please subscribe and hit that like button. So anyway, take care. I'll see you next time. And in the next episode, in case you're wondering, we're going to be looking at overtones, harmonics, and partials, basically those aspects of the frequency spectrum that make up the tone color of sound, which is at the heart of synthesis. See you then.